Hello. So next start with our next tutorial. The topic is datasets and data loaders. So the a typical machine learning project is divided into two parts. First part is data pre-processing and second part is training or modeling. So the purpose of these two classes is to decouple the code of data pre-processing from data training or modeling, and that results in better readability and modularity. So these two classes are available in these packages. Data loader is available here, torch.utils.data.dataLoader, and dataset is available here, torch.utils.data.dataset. And this can be used with preloaded datasets, or they can be used with your own dataset also. And the dataset class stores the sample and its corresponding labels, and the data loader, it creates a wrapper around the dataset, so it's like an iterable which will help you easily access the samples. So basically the difference is dataset will store the sample and labels, and data loaders will create an iterable to access the dataset. So in PyTorch there are a lot of preloaded datasets available. Particularly the Torch Vision library has got a lot of image datasets for computer vision task. One of the many popular datasets you may have heard of is Fashion MNIST dataset. So with this dataset we will experiment and demonstrate how the dataset and data loader classes work. So we have to first do some imports. This capital dataset is the one that is going to hold the samples and labels, and the datasets with this small d is going to contain the datasets from Torch Vision library like Fashion MNIST. Right. Then we want to fetch the training data and test data. So in the datasets we have Fashion MNIST datasets, and there are typical 4 arguments required here. The first argument is root. So root specifies the path where the data is stored. Then next argument is train. So what we are fetching, whether it is train data or not. If it is train, then it is true. If we are not fetching train data, then it is false. Then whether we want to download it or not. So yes, true, we want to download it. And then if you want to apply any transform on it, then that is given by the transform argument. So we want the data, the samples, the images to be converted into tensor for further processing. So we are applying a transform here. We will learn more about transform in the next tutorial. So this is the code for getting the training data, and this is the code for getting the test data. And the only difference here is here train is equal to true and here train is equal to false. Otherwise they are same. Then we create a dictionary called label maps, where the keys are 0, 1, 2, 3, 4, 5, 6 up to 9, and for every key there is an atom. For example, 0 correspond to t-shirts, 1 correspond to trousers, 2 correspond to pullover. So these are different. So the Fashion MNIST dataset consists of images of these atoms: t-shirts, trousers, pullovers, dress, coat, sandals, and all. So we are mapping the title of the image to an index. Now here we are typically, this is a typical for loop to display number of images in a subplot using matplotlib. So we want to create, so let me just run this part and it will be quite clear. So here we just want to display these 9 images along with their labels. So you can see from MNIST dataset we have fetched a bag and a shirt and a pullover and a dress, coat, trouser, and the image size is very small. The images are only 27 by 27 pixels, so they are quite blur. They are not very clear. So this is boots, coat, t-shirt. So randomly fetched atoms are displayed here. So we want to display 9 atoms in 3 rows and 3 columns, and that is why we have columns equal to 3 and rows equal to 3. And then we want to iterate from 1 to 9. We want to iterate from 1 to 9. So the range starts from 1 and goes up to 10. When we add plus 1 there, then it is 10. So the iteration will stop at 9. So iteration always stops one number before the extreme limit. Yeah, so if it is 10, the range goes from 1 to 9. And here, this is the length of training data. So how many images are there in the training data? That particular count, I think it is 50,000 or something. I think there are 50,000 or something images. So this length will be 50,000, and from this 50,000 a random integer will be chosen. A random integer will be chosen as a tensor, and then to get that number from the tensor, if you remember in our last tutorial, we use atom function. So a random number is taken out and that is stored as an index. So it is a number in the range of 50,000. So that is like an ID. Then that on that particular ID there is an image. So we get that image from the training data, and at that location we get the image and its corresponding label. So suppose you get 20,000, so it will be training data in bracket 20,000. So at location 20,000 in training data there is an image and a label associated with it. So we will get the image as well as the label, and then I hope you know how subplot works. So here we have given row 3, column 3. That means 3 by 3 is the size of the total figure. That means it is divided into 3 by 3 subplots, and the value of I is 1. So this image we want to display at location 1, because right now I is equal to 1. So that is where the image goes, and we want to display the title as well. So we have got label of the image. Now the label is in the form of index from 0 to 9, and we want to convert that 0 to 9 into the actual title like bag or shirt or pullover, which can be done using this dictionary, and that is why we created this dictionary. So if the label is say 4, then the dictionary will return coat. If the label is a 7, then the dictionary will return sneaker. So likewise, we fetch the title from the label number, and that title is displayed on top of every image. Axis is off, so no axis will be displayed. And then we show the image. So plt.imshow will show the image, and it will be shown in grayscale, and this image is shown, and this squeeze function is actually used to get the proper dimension, because the image dimensions are specified as 1, 28, 28. The image is always specified by 1, 28 by 28. So if you want to remove that 1, then squeeze function is used. So if you just if you just give img dot shape, you get 1, 28, 28. but we don't want 1 here for displaying in matplotlib. We just want 28 by 28. So if you simply give img dot squeeze and then you call its shape, then it will give 28 by 28. So we want 28 by 28 here. That's why we give this squeeze function, because it removes if there is one associated with if there is a one in the dimension, one of the dimension is one, then that will be removed. So it becomes 28 by 28, and this is how it will display the first image. Then in the second iteration of the for loop, it will again randomly choose another image, take its ID, and from that ID get the image and the label, and then now it will be displayed in the subplot at location 3 comma 3 comma 2. That means this shirt, first one was bag, second is shirt. So this I indicates the location inside the subplot. So the value of I is 1 here, then 2 for shirt, 3 for pullover, 4 for dress, 5 for coat, 6 for trouser. So the value of I goes on increasing. Then again it will display the title using the dictionary, axes are off, and again display the image. Likewise it goes through the for loop 9 times and display 9 images in subplot. So this particular configuration is called as subplot, a plot inside a plot, number of plots inside a plot. That is why it is called subplot. Yeah. Then let's try to use a custom dataset. So a custom dataset must initialize or implement these three functions: init function, length function, and getItem function. So the images are stored in a directory called image directory, and the labels are stored in a CSV file called annotation directory. So we have to implement a class which should implement all these three functions: init function and length function and getItem function. So this is a class which has got these three functions, and the dataset goes as an argument to the class. So typically this is an initialization function where we pass the annotation file which is a CSV file containing all the labels of the images. This is image directory, which is a directory which hold all the images. If we want to pass any transform that we perform on the dataset, then this is here. And then target transform means the transform which is performed on the target or the label. So like a typical initialization method in object-oriented programming, the image labels are assigned from the annotation file, and the image directory is assigned to self image directory, and the transform is assigned to self.transform, and target transform is assigned to target transform. So this is the class variable actually. So this is the first function. The second function is length. So basically length will return the length of image labels. So all the labels that are there, what is the length? That means it will return the number of images in the particular data set. And here in the third one, so here we have to get an atom, particular atom, when we pass an index. So in the first line, it will get the path of the image using the index. The path of the image using the index. Then in here, from that path, it will read an image and store in the image variable. And here from the index, we will get the label of that image and store in the label variable. And if user has specified any transform, then that transform will be performed on the image. If user has specified a transform for target or label or class variable, then that transform is performed on the label, and finally it returns the image along with the label. So this function, when given an index, returns an image and the label at that index. This method returns the total length of the dataset, and this method does the initialization for us. These three methods or functions are to be it is necessary to implement them if you want to use your own custom dataset. Then let's try to understand how data loader works. So here we are talking about dataset and data loader. So I have told you that dataset is used to store the samples along with their labels, and data loader is like an iterable which makes it easy for you to iterate through the dataset. So the data loader will take training data as one of the argument, and then it will create batches of 64, and then if shuffle is equal to true, that means the images will be shuffled after every epoch. So this is like a constructor which creates this train underscore data loader, which is an iterable. It's a wrapper, it's an iterable for training data, and similarly this is a wrapper or iterable for test data. So the data loader class creates mini batches, it reshuffles after every epoch, it is an iterable, and each iteration returns a batch, and after we iterate over all batches the data is shuffled. Basically after every epoch data is shuffled. So again we will try something similar. So in this case we will just display one image using data loader class. So yeah, so from train data loader we iterate over it and get the next atom, and the next atom is basically a batch. So when you iterate using data loader, you keep getting batches one after the other, you keep getting batches. So we get the first batch, and in that first batch we have number of images as train features, number of labels as train labels. From there now we can display the shape. So the shape of the first batch is this, so it's like it has got 64 images, and every image is 1 comma 28 comma 28. Because it's a grayscale image, so it will not have 3 channels, it will only have 1 channel, that's why it is 1 here, and 28 by 28 is the pixel size of the image. So 64 image grayscale 64 grayscale images of size 28 by 28, and in the same way we display the size of train label, so that we get as 64. Because there are 64 images, so there are 64 labels associated with those images. Now again we squeeze it, and the purpose of squeeze function is same as I have explained earlier in this same tutorial. So you squeeze it and you get the image and you get the label. So we have given 0 index there, that means we are getting the first image in the batch, we are getting the first image in the batch, and we are getting the label of the first image in the batch. We display the image, and that's it. In the end we display the label also. Yeah, so if I run this I get this. So here label is equal to 8, label is equal to 8. So if you check at label 8, you get a bag here. If I run the same code again, in that case we get something else. So when I run it again, it has iterated over the data loader, so it has gone to the next batch, not to the next image, it has gone to the next batch, which again contains 64 images, grayscale images of size 28 by 28, and here we have displayed the first image which is at index 0, whose label is 1, and at label 1 we have a trouser. That is why we get a trouser here. So that is how dataset and data loader classes work. I hope the concepts are clear. Thank you so much. Bye for now.